Ana es la consultora principal de EOC, que es una consultoría de olores con base en Canadá. Tiene más de 23 años de experiencia en el sector y ha hecho estudios en todo el sector de tratamiento de aguas y tratamiento de residuos. Ha publicado alrededor de 25 artículos y presentado en conferencias y fue parte del grupo EE6, que es quien regula la estandarización de olfatometría en los Estados Unidos del 2010 al 2013. Es una miembro activa de el Air Waste Management Association, Water Environment Association, International Water Association y el AMST.
This morning I was listening to the great presentations of different people and about the different regulations in different countries or different sampling methodologies, evaluation methodologies in different countries. It would be really nice and great to have one regulation and one sampling standard procedure for odor sampling and for odor evaluation. Then we'll end up with the same results. But at least in Canada, I did so many studies showing that even if we sample at the same time, at the same source, using the same equipment or similar equipment, we might end up with different results. And the factor is really very large. Like we have experience of results having 10 times difference. Then if we have a regulation in Ontario, Canada, because I'm from Canada, regulation guideline of one odor unit at any sensitive receptor, then actually one odor unit might very easily be 10 odor units. Depends who do the sampling, who do the evaluation, etc. There's so many factors. I was about to change my presentation because I had another presentation a few years back saying how reliable are odor assessments. Then I listed all the factors influencing the final results for odor sampling and evaluation. But today my presentation is about the sampling at the source and using different dilutions and showing the results, the different results for that. That's only the limitation. But if you have any other questions, then I will be pleased to answer. Then I divided my presentation into the sections, how to deal with the complaints. Then I will talk a little bit about the introduction of odor sampling, how to measure the odor. And then I will briefly mention about different standards and guidelines used around the world for sampling. And then I will introduce 6 studies. I will introduce the methodology used for my studies, and I will end up my presentation with conclusions. In Canada, odor is considered a nuisance. You have to demonstrate that odor causes the adverse effect. We have the standard of a guideline of one odor unit at any sensitive receptor. But people have a right to complain about the odors to the Ministry of Environment or to the facility causing the odors. Then the ministry has to actually send someone to validate the complaints. However, if the complaints are persistent, then the ministry is capable of giving the order to the facility to investigate the odors. Then how can you validate the complaints? Complaints can be validated by basically odor observation. It means by doing the community odor survey, sending independent people to the area and downwind from the in question facility and upwind to see if there is any background, and doing the observations. I have another paper about the community odor survey, which was we are allowed to do the ambient sampling. It means collect the samples downwind from the facility in question facility. then it's very common. Then we do the in-source testing together with the ambient sampling. There is another procedure for ambient monitoring using different like portable olfactometers. But as I said, in Canada, in Ontario, we use for the compliance purposes, we use source sampling. It means you have to investigate each potential odor source and test the source, and then collect the samples at the source. Collect the sample at the source, and then do the evaluation using the odor panel, and predict the off-site odor concentration using the model. You can also calibrate whatever the model would predict. You can also do the ambient sampling at the same time as the source sampling, and then rerun the model for actual hour and actual day of ambient sampling to see if the model for that hour will predict whatever you measure downwind. There are different types of the sources, as we heard before. We call it point sources for the stack or vent. We use the dynamic dilution sampler for that reason. Area source, which might be lagoon. There is a procedure using the flex chamber or wind tunnel technique for the collection of the samples from the area sources. Might also give the different results, depends on what you use and stuff like that, but I would like, there's no time to cover that. And fugitive sources, which are very often omitted, but they might be a very like a main odor source at the facilities. We had a project when nobody paid attention to the fugitive sources, but actually when we did the testing at the all sources, point sources, area sources, and fugitive sources were the main odor source at that facility. They are very often omitted because they are very difficult to measure. I developed a methodology which also was presented at one of the conferences for measuring the fugitive sources. Then when we collect the samples at the sources, we have the similar procedure, which I will talk later on about the standards for sampling. We collect 3 samples at each source and do the evaluation for odor detection thresholds values. We can also do the same to calculate the offensiveness thresholds values or complaint thresholds values. It means we can predict when 50% of population will say that the odor is offensive, or they will complain about the odors. There's another paper also about that. Then based on the odor detection threshold value and measured flow rates, we calculate the emission rates, and then the emission rates we use for the dispersion modeling to predict the offsite odor concentration. As was mentioned before, there are different standards for sampling and evaluation, but I would like to just talk about the sampling, because I think that the sampling is critical. If samples are not collected correctly, then, as I said, what's the point of doing the same sample evaluation, to do the evaluation, the same sample 3 times, introducing 3 times, then if you already lost the odor by a factor of 10, then but there are different standards for sampling, as was mentioned before. The European standard, Australian, New Zealand standard, German VDI. I think, yeah, I put right 380. I wasn't sure. And in United States, the ASTM. But it's about the evaluation. 679. It's about the evaluation. I was the chair of the committee 6 for standardization for odors between 2010 and 2013. We tried to develop the. It's still in draft stage, this sampling methodology standard, but still in draft stage. In Canada, we used to have the draft standard in 1989, which right now it's Ontario Source Testing Code Method ON6, which was approved in 2000. 12. Then in EN standard, there is limited information how the samples are need to be collected. VDI, it's a great standard, but in Canada, as I mentioned, in 1989, we had a draft standard which required to find the optimum dilution during the sampling for each source. Finding the optimum dilution, we had to collect at each source 12 samples, triplicates at 4 different dilution, and find the optimum. It means optimum dilution was defined as the minimum loss during the sampling. In the new 2010 guideline, the ministry said only 3 samples collected at dilution, and it was calculated that you have to be above the, you cannot really have the water condensation in the bag. But based on my 23 years of experience in sampling and evaluation, then I think that's not enough. Then I studied so many. My presentation today is based on six studies, but I have more data showing that every time we collect the sample at different dilutions, if the dilution is too low, then your final number is also low. Then for the methodology for all six studies, we use the for diluted samples, we use the dynamic dilution sampler, which is the sampler capable of diluting the samples on site with nitrogen. The sampler is calibrated before sampling at different temperatures. That's also important. And for undiluted samples, we collected using the lung sampler. It basically just to pull the sample from the source. Sampling time was 10 minutes per sample, but we collected 3 samples per source. Then right now, I think that the new guideline says 20 minutes. Then the bags were, we used the Tedlar bags, the clean Tedlar bags. The bags were cleaned according to the procedure required by the Ontario Ministry of Environment, which is in that guideline. Our bags were even cleaned for 48 hours at the high elevation temperature. Then our Tedlar bags, because Tedlar bags got the residue odor, even 100 other units. If someone is using not clean bags, then you've got already 100 other units in your bag. Then you have to pay attention to clean the Tedlar, and then make sure that you have bags clean with no residue odor. Then samples after the analysis were covered in dark containers to prevent any photochemical reactions. Evaluation was done by dynamic olfactometry. In Ontario, there is a requirement. We cannot use the like 4 people for evaluation. We have to use 8, because if you calculate the 50% of the population who will be detecting or complaining that ministry is not allowing results based on 4 people. Then we follow the EN 1375 with the exception that we have to use 8 people, and we don't have to introduce the same sample 3 times because based on experience, if we have, for example, for one day 12 or 18 samples, if we start evaluating them, because we evaluate them right away within like 6 hours or 4 hours from the sampling, then you end up with people being tired, and the responses are not so great after so many hours of sitting and sniffing and using the same people for that purpose. Then for this study, the evaluation were done within 4 hours. Then we calculated the odor detection threshold values for these samples. Then first 3 studies were done when we collected undiluted samples and we collected diluted samples at the same source, point source. For that study number 1, it was a paint facility. It was a source with the high temperature. We collected 3 samples at 50 times dilution and at the same time 3 samples and undiluted. These are the results we use for the calculation the geometric mean. I didn't put the geometric mean. It means we used the 50 times 3 samples. We call it raw odor detection threshold value. It means the number we used, that's the number for evaluation, and then you multiply. Net OTV is the dilution used on site, multiply by raw OTV will give you 31,000 for this case. For sample number 2, 500. Then as you see, the factor is great, like between the diluted samples and undiluted sample, 31,000 versus 2,100. Then if you calculate the factor, that would be probably 17, whatever, times 15 times difference. Then again, it might be 1 odor unit or 15 odor units based on just on the sampling procedure. For the case number 2, there was a humid source. We collected 3 samples at 30 times dilution and 3 samples undiluted. Again, the evaluation was done within 4 hours. Then when you look at the results, the factor is probably 10 times already. Case number 3, another humid source, 3 samples collected at 80 times and 3 samples collected undiluted, evaluation within 4 hours. Again, 9,600 versus 1,100, or 8,000 versus 1,400, 7,200 versus 1,150. Then the odor losses is between 9 and 17 times if samples are not diluted for the high elevation sources or humid sources. The study number 4, 5, and 6, then we use the different dilution at the same point source. For the case number 4, it was a pet food facility for study for the for the inlet of the odor control unit. Then we had the cases when we were hired to correct another consultant because based on their results, the efficiency of the odor control unit was even minus or in the range of 50%. When we did this study, the efficiency of the odor control unit was 90 and above. Then we collected 3 samples at the 60 times dilution, and at the same time, 3 samples were collected at 9 times dilution. Then look at the results. I have only 1 minute, sorry. Then again, almost 60,000 versus 8,000. For the number 5, it was the food facility. We collected 3 samples at 50 times and 3 samples at 20 times dilution. Again, the big difference between the different dilutions. Then study number 6 was the sewage treatment facility, 200 times versus 50 times. These are the results. Then conclusions would be then you have to really use the dilution when you are sampling the sources, hot sources or humid sources. But there is also unknown what to do, how to collect the samples, what dilution to use for the sources. Then we discovered that if you are using too low dilution, then you might lose odors. But it would be nice to have other data using other people and comments from other people. Thank you.
Thank you for your presentation. Just a quick question. When you were taking the samples without dilution, were you having condensation on on the bags?
Yeah.
Or
Yeah, that was the purpose on undiluted samples. Yes.
okay, so you were getting
Yeah, that's the
condensation.
reason. Yeah, because some
Okay.
people. Yeah.
Okay, thanks.